4, problem 47 reads, a 75-kilogram man steps off a platform 3.1 meters above the ground. He keeps his legs straight as he falls, but his knees begin to bend the moment his feet touch the ground. Treated as a particle, he moves an additional 0.6 meters before coming to rest. So, first, what is the speed the instant his feet touch the ground? So this is simple kinematics. Initial velocity is 0, final velocity is what we're looking for. Acceleration is 9.81 due to gravity. I have it negative, but it doesn't really matter whether it's negative or positive as long as you're consistent. Displacement is going to be 3.1 meters. Time doesn't matter. So we use our velocity squared equals initial velocity squared plus 2AD. Just solve for v by square rooting both sides. Plug in your numbers into a calculator. So v equals the square root of 2 times 9.81 times 3.1. And his final velocity when he hits the ground is 7.8 meters per second. So part B, if we treat the man as a particle, what is his acceleration as he slows down, if the acceleration is assumed to be constant? So his acceleration direction is going to be up, since he is already falling down Since he's falling down, his acceleration is going to have to be up to stop him. So we set up another kinematics thing. Our initial velocity is our final velocity from the previous problem. His final velocity here is 0 since he's coming to a stop. And his displacement is 0.6 meters. So we can use the exact same equation we did here, v squared equals v naught squared plus 2AD. I'll rearrange a little bit. So our negative initial velocity squared divided by 2 times the displacement, which I have as negative 0.6 since I have down as negative. Plug in the numbers, so 7.8 squared over 0.6 times 2, our negatives will cancel out, will equal our acceleration, and his acceleration is 50.7 meters per second squared going up as he stops himself from falling. Part C, draw his free body diagram. In terms of forces on the diagram, what is the net force on him? So, his free body diagram, as he's hitting the ground to slow down, the force of gravity is pulling him down. Force normal plus his feet is pushing up. I just count that all as force normal here, so you could have 2 smaller arrows instead. So his so then it says, using Newton's laws and the results from part B, calculate the average force his feet exert on the ground. So first we need to find the net force acting on him. So our net force equals his mass times his acceleration. His acceleration we found previously. His mass is 75 kilograms, so force equals mass times acceleration, multiply our mass and acceleration, and the net force exerted on him is 3,802.5 newtons, pushing him up is his net force. Then we need to find the force his feet exert on the ground, which is going to be equal to the force normal here, since for every action there is an equal and opposite reaction. Sorry, I'm tongue twisting myself here. So instead of F net, we'll use N, which is the force normal, what we're looking for, minus the force of gravity, which is mg, will equal our 3,802.5 newtons, because that's his net force. So his force normal will equal mg plus 3,802.5. So force normal, plug in your numbers and throw them in a calculator, and the force his feet are exerting on the ground is 4,538.25 newtons. In terms of his mass, that is about 60.5 times his mass. So that's a lot.